Hi everyone, welcome to this coffee break. My name is Christophe Bordeleau. I'm product manager at Eddyfi Technologies. Today we're going to be talking about robotics. We're going to be looking at what are the drivers, a very high-level discussion, why we're seeing more and more robotics, why now, what happened. So let's jump right in. If you have any question, feel free to post them in the chat, or you can ask me a question by email later if you want to. So the why, the what, why now, basically, because we're seeing more and more robotic crawlers, robot drones for all kind of inspection. But why are we seeing all that right now? Obviously, there is an endless list of reason. Factory drivers. We typically categorize them or look at them in four key category for the drivers and the reason. But the important part is we see more and more the asset owner being implicated in this change, driving the change. There is a crave for better data or more data. And obviously, the technology make it possible right now to implement crawler where a few years back it was not as efficient or as mature. Definitely like the why right now. We can see the general labor shortage all around the world. Obviously, the COVID situation we don't want to mention, but it definitely fast track a few for a few years changes. So if we look at the drivers, typically the way we look at it is in four buckets. The four main reasons why people will use robotic at the end of the day. It's either safety, environment, operational efficiency, and direct cost avoidance. So there's a small difference between the efficiency and the cost avoidance. We're going to go to that after, but typically by going to robotics, you're going to save in all or some of these category. And that's why most people are after. So for an asset owner, the safety environment might be more important. And for a service provider, the driver might be a little bit different. But at the end of the day, they're all in these four buckets. So talking safety, I think it's pretty straightforward. People that were on site or used to do on-site inspection easily see why and where we can save in terms of safety. So we can talk about the confined space entry, of course, just the scaffolding when we're working at height. So not only the rope access or going there, but removing the scaffolding, there's a risk. There's some application where you remove or work with insulation, or you work with dangerous chemicals or radiation or so on and so forth. Just being on an offshore manned facility. So if you can reduce your staff, you're definitely going to increase your safety, reduce the risk basically. So in the same areas, so if we look at concrete example, I was talking chemicals, radiation, stuff like that. So even if you don't do an old job with a crawler, if you can just reduce the exposure, so if you can do, I don't know, 50%, 60%, it's still a huge gain in terms of safety because the exposure is going to go down. Obviously, we want to, if possible, we're going to bring that to zero and we're going to do everything with a crawler, but not out, and it's not always possible depending on the access or how the asset is designed. Less scaffolding or no scaffolding, again, the same idea, and just avoiding or minimizing the time people spend in a dangerous or critical environment. So as you can see in the picture, sometimes the weather is nice, but most of the time we're not going to be that lucky, or it's going to be different condition, and like it's not fun even for people. So there's some high-risk job that are not, like, even people performing the job don't really want to be there. So by using crawler in combination, so it's not always going to be a 100% crawler, but just by using that as an extra tool, it's a way to mitigate the risk, obviously. Direct cost avoidance. So that's kind of wide, but for most part, just by reducing risk, we're going to avoid some costs related to it. We can think about confined space entry. So you need a bigger crew, you need a protocol, what happens in terms of emergency. You need people to check you if somebody's going in a tank. You need a bunch of equipment, airlines, so on and so forth. So if you can remove that or reduce that, obviously that comes with a saving in terms of cost to perform a job. And that's pretty much the same for all the safety benefit. On top of that, we can also see improvement in the way the inspection is performed. So a good example for that, if we look at, say, the RMS that's doing mapping or UT mapping or an XY crawler, you can automate a big chunk of the inspection. So you can just install a crawler. You're gonna have your inspection plan before, then you just run and make sure the crawler is performing well. But you won't have you don't need to stop for the crawler to take a break or anything. So you're gonna have a better coverage, typically faster, and then after you can look at better reporting or easier reporting. Like you don't have to spend as much time doing the report. A big chunk of the report is going to be pre-made by the software. Looking at the operational efficiency, which is a bit different than the cost. So if we look at this data, for instance, on the left is typically what we collect as of today. We spend analysis, but the reality is we're looking to have something that looks like on the right. What does that mean? So during a typical inspection, data is all around and like it's spread out. You don't necessarily have the contextual information. You don't know where it is. You don't know how it looks. You don't know. You just have a piece of data. And when you do the reporting, you're trying to articulate that in terms of making it clearer to understand or give better information to the asset owner or your end customer. Obviously, depending on the time you spend on the report, the tools you're using, you're probably going to end up with something in the middle. So depending on the time you spend, it's going to be either something like the raw data on the left or in between with the analysis on the right. But realistically, what you're looking at to make any decision, it's something like on the right. And that's hard to achieve as of today, either because, again, lack of context, not enough data, hard to articulate everything. And that's where using the crawler or using a robot or using a better software, so in a combination of all of them, helps to put context for your data. So when we talk about the crawler, we can see some stuff like permanent record of inspection, digital twins. So if you go in and you look at photogrammetry or different ways to have digital twins, you can now overlay all your information on the asset, which basically show it's a better way to show the data. More information is there, and it's a better way to track over time what change. So we're basically looking at more data and better data. And at the end of the day, that should lead to better decision making because you're as good as the data you get. So if you get poor data, your decision making is going to be affected by that. So if you can have a better way to take the data and to compute the data, then you're going to have, at the end of the day, an asset performing better. You're going to be more optimized in terms of cost, the maintenance cost, the planning of your future shutdown, and so on and so forth. So there is a lot of value there in the added information, which a few years back was not possible, just the lack of technology, or we were not there yet. But now we're moving faster and faster toward that direction. Finally, the environment, the fourth driver. It's kind of straightforward, really. We've seen other way to save. The environment is typically related to that. So if you're going to have better data, if you're going to have inspection in operation, if you're going to have access to dangerous goods or places where you couldn't go before, this will allow you in terms to minimize the risk for the people, but for the environment. So if we think about the nuclear application, for instance, just to make sure that the waste or the tank containing the waste are in good shape over time, it's kind of hard to send somebody out there just because of the radiation level. But if you have a crawler, you can inspect, monitor over time, and you can reassess the risk for the environment. Is there any leak? Is there any problem? And you can react faster. We can think about potable water system by going in and inspecting more frequently, or even in operation in some cases. You're going to be able to pinpoint where are the leak and minimize the leak, minimize the waste in the system, and at the end of the day, optimize the environment or the efficiency of the system. We can also look at like risk of failure, obviously, for bridges inspection, sewer, storage tank. They all have environmental impact if it happens. Obviously, depending on what's the asset, the risk is higher or lower, but having better data or more data and continuous inspection and a consolidated inspection plan will help you in the long run to minimize those environmental risks. And we do know that today, well, for many reasons, but it's becoming a more important factor to consider when doing long-term exploitation of assets. So that's for the driver. That's all good. But at the end of the day, what does that mean for how we look at it, how we approach a problem with robotics? Because even if I know what are my the reason to buy one, do I need one right now? Should I buy one for an application? Should I buy one for what are the reasons? What does that mean in terms of solution? Typically, what we see is there is two type of either requests or ways to approach a problem. So we're seeing more and more the toolkit approach. Historically, it was more a custom package. So the custom package is pretty much you have either one application or a specific problem you're trying to solve. You know the ramification, you know why you need to solve it. So you typically have a good knowledge of the problem. You have a good analysis on what you're trying to achieve, what's going to be the saving at the end of the day, and you know where you're going pretty much. And it's going to be a tailored application. It's a bit more expensive, but the crawler typically does one thing very, very well and one thing only. On the other end, we have something that's, I wouldn't say new, but that we see more and more. I call it the toolkit approach or the screwdriver approach, but if you get a more generic system, so typically the investment initially is a bit lower than a custom system, but you get a system that works in many, many environments, and people now are looking at something they can leave on site, or they can basically give to their team with no, like they have an idea of what it's going to be used for, but there's no specific purpose. It's basically a tool you give to your team, and your team now can use it in a wide different, like they can use it in a different approach. You can use it for tool, for inspection. They can use it to do stuff you weren't expecting initially. So the custom approach, application specific, as I said, it can take different form. It's typically very high value solution. So it typically solves big problem, or at least critical problem, or it prevent critical problem. So looking at a few of these, like we have, as I said earlier, storage tank inspection for waste, nuclear waste. We have bridge inspection crawler to make sure bridge is in good shape, the harmonics are not disturbed, and the vibration is okay. We have long range pipe crawler for specific weird shape pipelines that are not pickable, or that there's another problem basically. So we're looking at a wide variety of crawlers, and it's typically very application specific. And as I said, the other approach, which is, I find it quite interesting in the sense that people are not looking for a crawler that does only one thing. They're looking at a crawler that does several things well. So you can think of it like if you buy a car, you don't necessarily have one reason to buy your car. You don't know what you're going to do tomorrow with your car, but you do know you need one in case something happens or if you need to do something. So depending on how everything evolves, you're going to need your car for several things. And if you need to, I don't know, tow something, you're going to have an itch. So you can customize it a little bit and it evolves with your needs. That's what we're seeing more and more. So we're seeing more and more people saying, I want a crawler to leave on site if something happens. I want it to be super simple. I want it to be flexible. So if I need to last minute add something on it, I can. If we need to change something, we can then develop a new thing, a new accessory to go on it. So it's very versatile, and that's a very interesting approach in the sense that it doesn't solve one problem, and it's different way to justify the need of a crawler, basically. And why we see more and more of that, and why it's interesting, it helps basically improve where we wouldn't expect improvement. It helps get the team on board with using a crawler and see it as just an extra part in a tool set. That's what we call it, the screwdriver or the toolbox approach. Is it gets integrated in the maintenance process. Some people will say, oh, I want to put a tool on it, and they just do something or ask for something more. They use it to move around some components, maybe to look around a corner they were inspecting before, or they weren't looking at before because they had no tools to do it. So it helps people and teams on the ground to go a bit deeper. And at the end of the day, it's something that typically is like the return on investment is pretty quick for that kind of unit, even though it's not a traditional, I have a problem, that's how the problem cost me, I need to fix it. On top of that, what it gives you, if you have like an extra toolkit, is for any emergency intervention or any unforeseen things, you're going to have a faster turnaround. And at the end of the day, we've seen some cases where, I don't know, you're trying to retrieve something. So a search and retrieve of parts or components in critical environments, so it could be a pipeline, could be a tank or whatever. And just the fact that they had a crawler handy, it basically took a few minutes/hours to solve a problem that would, at the end of the day, delay the old project, the old assessment, and might cost hundreds of thousands, basically. So what we're seeing again, and it's kind of a shift in mentality. People were always asking, like, typically people were asking how to justify something or how to justify the crawler. And now what we're hearing more is how I cannot not afford one. You need to have one because the cost of not having one is becoming more and more important. And it becomes the same thing as you would equip all your team on the ground with minimal tool set. Like your maintenance team are going to have a toolkit with some tools in it, and you're not going to start arguing why they're going to get a screwdriver or a hammer in their set. Like, you're going to supply a basic set, and crawler are becoming part of that basic set. Obviously, it's still evolving. Crawlers are still getting better and better, but it just shows the shift in mentality compared to where we were a couple of years ago. And at the end of the day, it's still the same driver, the same reasons, but the technology make it possible that we can now use it easily and quickly. I hope this was kind of useful. It was a super high level, super quick presentation, just going over the mentalities with the shift we see on the ground. and how we address it. Hopefully, if you don't have a crawler right now on the ground or a drone or anything, it's gonna push you to do the extra step. But yeah, thanks for watching. I'll just switch to see if there's any question that happened while I was typing. Oh, here we have a few questions. Oh, so the first question, how fast is the typical return on investment? I kind of allude to that a little bit. I said it's quick. Of course, it depends on the exact application. So some are going to be super quick, some are going to be super long. Typically, so in best case scenarios, what we've seen, we were talking a few months to get a return on investment, which is pretty good. But typically, worst case scenario, you should get a good return on investment. So your money back, but when investing in a system, because that's an investment in a year ish. So we're talking 10 to 12 months. So it's bigger investments. Sometimes it's not nice to put money up front when either you don't have a use to it right now, or you're not sure if you're going to use it. But typically everybody uses it, and the money back is pretty quick. What do you think is the next big thing in robotics? So I guess it's going to be really around data management and data collection, the quality of data. So everything related to that. So I mentioned it super quickly, but we have the digital twins, everything around positioning, because the accuracy of how well you're positioned or where you are is really going to be a key factor on how you can clean that data. So we were talking about the 3 stages, so the raw data, the analysis, and the decision state, which we're looking or driving for. All the technology needed to go there is going to be around positioning, data management, software improvement. All these kind of tools are going to be changing quite a lot in the next few years. It's not going to be one big jump, but just as we saw with the cars, with the positioning and the way the autonomous driving and stuff like that. So we're going to see part of it move to the industrial stages. So we're going to see part of that development affect industrial robotic in the next few years. So the crawler are pretty user-friendly. So typically we're looking at realistically, we're looking at a few minutes to set up a crawler. Obviously you need to do procedure before that, make sure you have a plan. But when you have your plan in place and you want to deploy, we're talking like a couple of minutes. It's really, really quick. It's pretty simple interface. So you can use the joystick to drive around. You have advanced feature, obviously you can learn on. Typically what we do is we provide a blended training. So you have a few class, e-learning class online. So you can take, it's a couple hours, nothing crazy, but it's going to show you more advanced feature and how to use the feature. And we give with that a 4-hour of support. So if you have additional questions and stuff. So the learning curve is pretty quick. Obviously, there's a lot of advanced feature. So that's going to take a bit longer, but the base stuff, so if doing a scan, inspecting, saving data, exporting data, it's pretty quick. We're looking at hours, basically, and a few minutes to set up the crawler when you know what you're doing. The type of risk, any trends where the robot remote deployment plays a role in mitigating the human risk factor. So right now the trend are on the easy, let's say the first thing we're trying to solve, and we get the low-hanging fruit for instance. So high risk area like confined space, work at height that I mentioned, everything around radiation. It's really where we see a lot of movement, because obviously these are the worst areas. So the gain is going to be much higher, or the pros to get a crawler is going to be much higher. If you can remove entirely a man entry on a confined space, in terms of safety, in terms of cost. It's a win all around. So we see a lot of demand there, a lot of work and effort there. So I'd say that's probably where we're gonna see the most safety mitigation in the next few years. Concrete example on the tool case and the screwdriver toolkit approach that I mentioned. So maybe one of the best we've seen was a company asked for a crawler with all the accessories you could put on it. So we're talking manipulators, we're talking cameras, a spare of a few things, and all the tools basically to play with that. And they just purchased some crawler to distribute around many sites around the world just to test, give them to their crew just to play with it. So it was kind of the first step of the screwdriver, the toolkit approach. And at the end of the day, it came back with a bunch of amazing feedback. Already just in that first phase, they saw some improvement in the way people work and the way people deal with it. And sometimes it doesn't need to be fancy, but if you have a crawler with a manipulator or something, we've seen cases where people will temporarily like zap strap or tape something on it to perform something they couldn't before, and just opens the possibilities. Obviously, after you're going to replace the tape or something with something more permanent, but at least like it helps people to try new stuff and make improvement where they wouldn't typically. So the price range, so it's a pretty broad price range. So if we talk about like the toolkit approach, so we're going to be looking at generalist crawler that can do a bunch of things. So typically it's going to be ranging for the complete system, so controller, software, tether, crawler, in the 60,000-ish to the 150,000. Like the 150,000 being like super high capacity crawler that can basically pull me up a wall or stuff like that. So that's kind of the range. If you go into the custom solution, it really depends. It's a case by case. So we've seen like super small customization, a few thousand, but we've seen like huge project over years. So yeah, it really depends. But if you want to start, what I say to people typically is start with the minimum crawler that fits your need or you think is going to fit your need, and then we can add to it later. So if you find new stuff, if you find, oh, maybe I need a bit more lighting, a bit more, can I get a different manipulator? Can I get a different gripper or blah, blah? We can build on it and just upgrade your system through the years. So we can start with the general, typically it's a MAG 310, which is a magnetic crawler. So you can do magnetic surfaces, you can do flat surfaces, you can do large diameter tank, and like it's quite range what you can do with it. So typically that's where we start. So I think that's it for the questions. Well, thanks for watching. I hope it was insightful. If you have any question or you want to discuss, my email is showing right now. So you send me a quick email. I'll be happy to chat with you about it. And on that note, thanks for attending and have a good rest of your day.